Good evening. Welcome to the QCIS channel. We're all on this channel. You get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and this evening, and happy Thanksgiving. It is still Thursday. This is generally when I do my Thursday edition right here on YouTube, but on this channel, the QCIS channel. So you all know. But tonight's topic is going to be one, probably heard of ArcGIS and Esri and cartography, which when you deal with cartography, you're making maps, land surveying, geography, which it could be physical geography, human geography, environmental geography. Tonight, I'm going to talk about a branch of geography known as Geographical Information Science. It is STEM. Now, what is it? Basically, when we talk about GIS, we're taking data, we're storing it, and we are analyzing it. And the type of data that we are analyzing is geographical data. You could use GIS for climatology, meteorology. You can use it for oceanography. Land surveyors use GIS. GIS is prevalent when we deal with cartography as well. Cartography is when you make maps. I know the University of Maryland, under geography, used to have a curriculum called Geographical Information Science and Computer Cartography. You are seeing more and more GIS, emergency GIS. You can use it for locating criminals. That's how powerful GIS is. Now, again, let me share my screen and let's get into the nuts and bolts of what GIS really is. Now, of course, this is from the North Carolina Department of Transportation. They also use GIS. We call it Geographical Information Science. Some call it Geographical Information Systems. And let's go up top here. And when we deal with GIS, well, what is GIS? Well, I just explained it to you. You think about geography. What is geography? Well, under the association, that's the Association of American Geographers definition. So I'm going to give you the Association of American Geographers definition. Again, the Association of American Geographers definition is geography is the science of place and space. Geography is the science of place and space. Then we get into the Merriam-Webster's definition, which when we talk about geography from the dictionary, the Webster's dictionary, it's a science that deals with the description, distribution, and interaction of the diverse physical, biological, and cultural features of the Earth's surface. Again, questions geographers ask. Where is it located? Why is it located there? How and why are places different? How do people interact with their environment? Now, something that you need to know within geography, I just mentioned it to you a few minutes ago. We talk about the history of cartography. Now, when we deal with cartography, that's when you make maps and you see all kinds of maps made. You look at your Rand McNally, that's your road atlas. You look at your world maps. You look at your celestial maps. All of those maps are done by way of cartography. You even look at Google Earth. Well, the first maps were rock walls and clay tablets. Now, the uses of maps, so you'll know, are for three different reasons. Celestial. Well, now, when something is celestial, we're talking about space. Cosmographic. This is when we start to deal with the human element. And then the land element, we deal with the topographic. Now, the funny thing about the topographical maps is you hear that word in survey. And what are we doing when we are doing a topo or a topographical survey? We're locating points like your trees, your utilities, your edge of pavement, your railroads, your edge of building. And what are we doing with all those points we are locating? We are creating a map based off of the point numbers, descriptions, and coordinates. Early maps of the world. And I'm showing you an early map right now. You have it right here, Europe and Africa. So maps go back centuries. This is a world map. Your world map is known as a Mercator map. And what they've done with the Mercator map, they've taken the sphere, which that's the Earth, and they basically flattened it out. So you can see where all the continents, your latitude and longitude and your coordinates are. Then you have what we call a land map. This is a topographical map of Harpers Ferry, West Virginia. You see the creeks, and you see the mountains, you see the roads, you even see the names of the towns. It's your topographical map. You also see different patterns of maps. And generally your maps have a north arrow. They have a scale. They have a legend. You see this map right here. Names of streets. See houses. So you can create a map out of anything. If you look at a floor plan is considered a map because basically it has listings of your bedrooms, your kitchen, your closet. Here's another map. This is a city map. When we get into cartography, it is a very big field. Here's another map. It's a street map. Putting in different descriptions. Here's another map. Now we move on to what is spatial data. You see geography, under geography you have remote sensing, which the funny thing about geography, some of it is tied to land surveying or geomatics. So when we deal with spatial data, we're talking about location data. How many, what kind, and where. And we have a scale of data, local to global to beyond. And what is our data presentation? Your words, your charts, your graphs, your tables, or maps. And estimates are that 80% of all data has a spatial component. Data from most sciences can be analyzed spatially. And again, when we deal with geographical information systems, a definition of GIS, we talk about science. Now we deal with the system because basically GIS, geographical information system, links locational and attribute information. It's linking locational and attribute information, not attribute, it's attribute information. Remember that. And you see attribute when you deal with computer-aided drafting, which you can actually take a map when you're creating a title page for your plans in CAD, and you can place a map on your title page. with a north arrow. And basically, again, when we deal with geographical information systems, you're linking locational and attribute information. And what it does, it enables a person to visualize patterns, relationships, and trends. This process gives an entirely new perspective to data analysis that cannot be easily seen in a table or list format or on a paper map. So basically, we're going to explore data using GIS turns data into information and knowledge. So the exploration of the use of GIS, it basically turns data into information and knowledge. Now, the 5 components of GIS, you have your hardware, that's your computer, peripherals, and sometimes servers on which the GIS operates. Then you have your software, provides the functions and tools required to store, analyze, and display data. Then you have data. Data is also stored as a vector, raster, or attribute data. Then what about your methods? Well, your methods, their guidelines, specifications, standards, and procedures for collecting and analyzing data and applying GIS. And we have people. GIS needs people to ask questions, choose, collect, and analyze the data and interpret the results. As I move along here. Now, a complete GIS. As you see in this slide, you have your visualization. GIS as a tool to display spatial data on a map. This would be your visualization. Then you have your database management. GIS as a tool to store and organize spatial data. And in order to visualize your spatial data as a map, you need to have database management. So that means everything that you have collected and stored, you can put on a map, like land use, streets, districts, parcels, parks, sand, gravel, water table. Then you have GIS. That's a tool used to analyze so you can interpret the spatial data. Now, GIS, as you know, combines spatial data from many sources. Again, these are your maps. These are your topographical maps. This is your street maps. Again, you look at the land records, police, fire, water, wastewater, transportation. This is why GIS is a good major to go into under geography. Then you have your sources of spatial data. You digitize and scan maps. You can purchase, they're donated, and they're on the internet created by the user. Then you have your databases, tables of data, GPS, global positioning system, accurate locations. Then you have free sampling of attributes, remote sensing and aerial photography. Now, where have you seen that? In land surveying. That's where you've seen it. And under GIS, you have your cartographic database, your translation of existing maps, your digitizing of existing maps, multiple digital products and multiple paper products. Database, not easy to interpret. As you see all the points here. A lot of points when it comes to data. Visualization, worth 1,000 words. These are all maps. This looks like it's an ArcGIS map. Very important. And, one thing too is, a number of people, when we look at a map, they don't know how to read a map. They don't understand the scale, which is in miles or kilometers or meters. You have to look at the legend. And what's created on a map is the data that's collected. Again, your roads, your bridges, your water towers. That's what's on the map. Your interstate highways, your US highways, your state highways. Again, you have different types of maps. You have world maps, which are your Mercator maps. You have maps that have your coordinates that surveyors use when they go out and run a topographical map. You have your city maps, your United States maps. They all do the same thing. A map is a presentation or visualization of the data that is collected by people. Two ways to visualize data: the world and GIS. You use the raster, which we talk about the grid, that's in pixels. That's what pixels look like. A location and value, satellite images and aerial photos already in format. Then you have vectors, points, lines, polygons, features like house, houses, lakes, etc. Attributes, they give you the size, type, length, etc. 5 data layers are like features. You have your rivers. Now, where have you heard layers? In computer aided drafting. You can take a map, and if you don't want certain symbols on your map, you put it in layers, like this layer right here. It only displays rivers. This second layer only displays lakes. This third layer, it shows you all the capitals of the United States. The roads layer shows you all the interstate highways. And then your streets layer, that's going to show you all the streets. Again, ArcInfo, all your interstates. This is ArcGIS. This is what a map looks like. Turning data into information. Again, the use of a map. It's the state of Florida. Spatial analysis is not just a map. Asking you a question, interaction. It's the information that goes on that map. Something you need to understand too about maps. Maps and databases are interactive. Now, the goal of GIS is to better assist people and companies to do their work better, faster, and cheaper through visualization, which GIS provides users the quicker, more accurate representations of spatial data. Database management makes it easier to keep spatial data accurate and up to date. And of course, spatial analysis helps users make more informed decisions wherever spatial data analysis is needed. This is why when you look at your maps, are they updated? Some of them aren't. Well, GIS, you have to go out every year and collect data. This is why they can get a Rand McNally roadmap out on time, because they update it every year. Again, now, how are some ways, well, what ways is GIS being used? Well, again, just mentioned it earlier. Some ways GIS is used, they use it through emergency services, that's your fire and police. Environmental, that's monitoring and modeling. Business, site location, delivery systems. Industry, which is transportation, communication, mining, pipelines, healthcare, government, local, state, federal, and military, and of course, education, research, teaching tool, and administration. Defense management. This is what we deal with the military. This is Camp Swampy Marine Corps Base. There's a map. And you have the facility number, your name, your property record, your housing number, primary use. You have your facility dimensions, your improvements. And this is a map. Maps are very important. When you get a map, you have to understand what's on that map in order to interpret it. Real estate management. Again, you look at all the real estate in your cities. This is GIS as well. And I can tell you what this city is right off the top of my head. The city is Chicago. That's the Sears Tower. Right here, this is Lakeshore Drive in Lake Michigan. It gives you a 3D view of what the real estate is in cities. You look at education. These are 3D pie graphs. Now, this is not a map, but it does create graphs as well from the data that is analyzed and stored. What about utilities? Well, we all need utilities, utility management. Well, you have this map, tells you where all the utilities are. Transportation management, your traffic, your 3D buildings. This is your population. Public safety. Reading about public safety. This is when you get your police, medical, and of course your fire involved. Here's a vehicle theft. Well, they can use GIS, which goes through GPS in order to locate where the theft occurred. And this is a map. It could be a satellite image, Google Earth. There's government. I'm a construction inspector, so may need to do a survey, find out where the properties are located, find out where the lots are. You can create a plat from this, a survey plat, property line survey. Hospital facilities. Tells you where all the hospital facilities are. And this is a graph. ArcGIS. ArcGIS provides users with a complete GIS visualization, database management, spatial analysis. ArcGIS offers more than just GIS software, it offers GIS solutions. And the goal is to make users more successful. The ArcGIS family of products. So you have desktop GIS, which has ArcGIS desktop, ArcGIS engine, and this is what you call a Venn diagram, because you're going to have information from all 4 subtopics of GIS that's going to give you the total picture of ArcGIS. You have desktop GIS again. There's ArcGIS desktop, ArcGIS engine, ArcGIS Explorer. Then you have server GIS. That's ArcGIS server, ArcGIS server extensions. And you have mobile GIS. Mobile GIS, you can utilize this on your cell phone. And there's ArcGIS mobile, ArcPad, and you have data, which you deal with Esri data and maps, Esri Demographics, Street Map Premium, ArcGIS Data Appliance, ArcGIS Online Services, and from the Venn diagram, you have created the whole picture of ArcGIS. The ArcGIS server platform, so you'll understand it. Maps, data, models, globes, metadata. So here's a flow chart. Well, here's the author, the server, and then the use. You're using a desktop, you're using Explorer, Web Map Viewer. This is your phone, your mobile phone, open APIs, and enterprise environment. So basically, making GIS knowledge available to anyone. And it also integrates with other systems via standards. NC.dot IT GIS unit. Well, NC.dot is the North Carolina Department of Transportation, and they utilize the GIS standards and practices. So as a part of the North Carolina Department of Transportation's efforts to maximize the value of GIS investment in geographical information systems, data management, and access to data, they have developed geospatial standards and practices. The purpose of the standards and practices is to provide users with necessary information about the data to support improved linking of different data sets and to better manage the department's GIS investments. And if you want to know more information about the GIS IT unit from NC.dot, here is the information. So basically, with GIS, we're just dealing with a platform that analyzes, visualizes. We also collect the data and we interpret the data, and it's geographical data. Use it for topography, maps. In fact, GIS is a subcomponent or subtopic of geography. In geography, we have human geography, environmental geography. We have GIS and cartography, remote sensing, photogrammetry, which if you look at it, you can link GIS to land survey. GIS is STEM, it's science, technology, engineering, and math. It's to help us better analyze data. And it's going to continue to be big. So what I just gave you was an overview of GIS, and I showed you ArcGIS, but if you have Google Earth, and there are other GIS platforms out there, the popular one is ArcGIS. Basically, you're making maps, you're interpreting data from existing maps. You can take a sphere like the globe and create a Mercator map, which is flat, shows you the lats and longs of all of the earth. You can put time zones. Any data that you can collect, you can use it in GIS. And that concludes this topic on GIS. If you like what I just presented, please comment, share, and subscribe. If you're looking for some political and social content, check out my other channel, the 401 Talk Zone Radio Show channel. In fact, here's where you can find me on YouTube. For the 401 Talk Zone Radio Show channel, you can find me on YouTube, X, Rumble, and Truth Social. For the QCIS channel, you can find me on YouTube, X, and LinkedIn. And once again, happy Thanksgiving, and thank you for viewing this content from the QCIS channel. On this channel, You get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. Hope you all have a wonderful and gracious evening. And once again, be safe and happy Thanksgiving.